Hello, Professor Sargent here with you again. We're going to talk about random variables, discrete random variables, and for those discrete random variables, we'll be doing things like determining whether we've got a discrete probability distribution, graphing, computing means and standard deviations, and that'll be about it for the time being. So let's take a look at an example. Actually, before we do that, before we look at the example, a random variable, you're measuring the outcome of some experiment, some probability experiment, and we don't know what's going to happen in advance. So the value that you get is going to be determined by chance. A lot of times we use a capital X, unlike what you see in algebra, a discrete random variable. You may have heard elsewhere that when it's discrete, that it's countable. That is correct, but countable could mean either something finite or certain infinite things. So the way I express it is that a discrete variable, in this case, a discrete random variable, is something where there's a smallest distance between two different values. You might be counting 1, 2, 3, 4. You might be counting by halves, 0, 0.5, 1, 1.5, 2, and so on. So this countable idea is equivalent to there being a smallest distance between two different values. And that would be whether you have something finite or infinite. But continuous random variables between two different values, there is no smallest distance between two different values. And so you continuously cut up and find things in between. And we'll get to the example in a moment.